Hello, I'm Amara Rasgis, editor of Consulting Specifying Engineer, and I'd like to thank you for joining us for today's video conversation. Today, I am speaking with India Rogers about building fire safety. Hi, India.
Hi, Amara. Thanks for having me.
Yeah, well, here's a little background before we get started. India Rogers is the Associate Director at the American Chemistry Council, which she joined in 2022. She leads two industry groups, the North American Modern Building Alliance and the Foam Sheathing Committee. These teams support the safe and effective use of plastic building materials in resilient, high-performance applications. All right, well, thank you for being here, India. Let's jump right in. Why should fire protection engineers be paying special attention to exterior walls, specifically exterior walls of tall buildings?
Sure. Exterior walls of tall buildings make up a significant part of the overall building envelope. They need to provide all four barrier functions of the building envelope: thermal control, air control, vapor control, and water tightness, all while resisting applicable structural loads and meeting strict fire performance and other safety requirements. They also need to be aesthetically pleasing. Another reason is because of the increase in tall buildings. Increasing population growth in urban areas has led to an increasing number of tall buildings, and the combination of more and taller buildings with rising awareness of climate change and needs for improved performance of all buildings has led to innovative and energy efficient facade systems, exterior wall coverings, and exterior wall assemblies. Also, although the number of tall building fire incidents has increased along with the number of tall buildings, when viewed on a per capita basis, fire incidents continue to decrease, due in part to steady improvements in areas of fire protection engineering, building codes, and fire testing and performance standards. When viewed globally, tall building fire incidents tend to be more common in areas where building codes and regulations are absent, inadequate, or poorly enforced. On that last item, the best possible building codes and regulations don't do much good if there's poor compliance and poor enforcement.
Right, exactly. So what specific test methods and apparatus are outlined in the standard for evaluating the fire propagation characteristics of exterior wall assemblies? And then to add to that, what should fire protection engineers pay attention to?
Sure. As with other large-scale fire tests, the NFPA 285 test includes detailed descriptions of both the test specimen and the test apparatus. Specifying engineers should pay special attention to the test specimen configuration and composition and the window closure. NFPA 285 is an important test for two reasons. First, it's referenced in the requirements of the International Building Code, or the IBC. And second, it provides valuable information regarding an exterior wall assembly's inherent propensity without aid from a sprinkler system to propagate flame vertically and horizontally from a room where a fire has started.
Okay. What are the building code triggers that prompt the use of NFPA 285 for performance fire testing? And I think I have a visual aid here. Let me show you.
Yes. So the International Building Code contains several prompts where testing a wall assembly to NFPA 285 is required. The prompts are largely based on when certain combustible building materials are used in exterior wall assemblies that are required by the construction type classification to be of non-combustible materials, namely type 1, 2, 3, and 4. You can see that up top there. Some of the materials prompting NFPA 285 testing include combustible water resistive barriers, foam plastic insulation, metal composite material systems, or MCMs, high pressure decorative exterior grade compact laminate, or HPL systems, and new for the 2024 IBC, insulated metal panel systems and exterior wall veneers using a combustible adhesive to laminate a metal core to non-combustible facing materials.
Great, thank you. Let's move on here. Can you describe what an NFPA 285 test is like?
Yeah, so NFPA 285 is a two-story test specimen and test apparatus that's designed to simulate exposure of the wall assembly's interior face, exterior face, and full cross-section to a post-flashover compartment fire. The compartment fire is specified to follow the standard time temperature curve for compartment fires. The test is 30 minutes with visual observations and temperature data collected throughout the test. The temperature data is collected from 66, 80, or more thermocouples, depending on configuration, located throughout the test assembly.
Wow, so what determines if an assembly passes or fails?
So a few things. The NFPA 285 test contains a list of acceptance criteria. That includes maximum temperature limits for thermocouples in specific locations throughout the test assembly, maximum temperature rise limits for thermocouples in specific locations throughout the assembly, observe flames emitting from the test assembly, maximum temperature rise limits and flaming in the second story test room, and flaming beyond the intersection of the test specimen and the side walls of the test apparatus.
Right, so does the test relate to real world scenarios then?
Yes, so the NFPA 285 test uses two gas burners to provide the fire exposure. The first burner is located in the bottom room. It's called the burn room by the test. And the burn room burner is supplied with a controlled gas flow so that the room will follow the standard time temperature curve for compartment fires. This time temperature curve is widely used in test methodologies evaluating fire resistance characteristics. The second burner, it's called the window burner. It's placed at a specific location in the immediate area of the window head, and it's ignited at a point 5 minutes into the test. For historical perspective, the burn room burner with the window burner configuration traces back to the UBC 26-9 test that was developed in the mid-1980s. That test was an intermediate scale test developed to provide a smaller test, which was a 17-foot high test specimen that correlated to the original UBC 17-6 test, which was a 25-foot high test specimen developed in the late 1970s, designed to replicate the exposure from a real world fire. And so the two burner combination was necessary to achieve that correlation. Now, I mentioned earlier that NFPA 285 is designed to evaluate the performance of the wall assembly without the benefit of any assistance from an automatic sprinkler system. When the original UBC 17-6 and 26-9 tests were developed, sprinkler systems were not required in high-rise buildings. So I have a video of a successful NFPA 285 test and an unsuccessful test to give you a better idea of what you look like, so we can show that. Great, so here's a short 2-minute video. It's time-lapsed, and the test begins with the test specimen in place on the test apparatus and the window burner in place at the location required by the test standard. The burn room burner is ignited, as you can see, and the 5 minutes into the test, after which the test runs its course, observations are made, temperature data is recorded. As we view this video, note that the flame does not spread or extend very far up the exterior face of the test specimen, nor does it spread horizontally beyond the area immediately above the window opening. There's also no visual evidence of significant burning or flaming behind the exterior cladding, but burning within the cross-section of the test specimen is determined using thermocouple data. Also note, relatively little smoke is produced during this test. Another visual indication suggesting that not much is going on behind the exterior cladding. And you can probably, at the conclusion of this 30-minute test, the gas is turned off and the specimen is allowed to cool, but I'll let this go ahead and play through. Okay, so the gas is turned off and the test specimen cools before its removal from the apparatus. In most situations, testing clients will perform a post-test inspection of the test specimen to document fire damage and any other useful observations as to how the assembly and component materials performed during the test. And that information is very useful for purposes of research and development activities, as well as subsequent engineering analysis to extend NFPA 285 test results to alternate assemblies. And now we can watch the unsuccessful test. So this video is also sped up. It's much shorter. It's only 30 seconds. At the 6-second mark, the video jumps to 20 minutes into the test. I think you saw that. At that point and through the remainder of the test, you can see through the left side vertical panel joint visual evidence of flaming behind that exterior panel that extends to the top of the test specimen. And as the video progresses, it gets worse from there as the flame continues to spread behind the panels, and then the panels themselves are consumed and fall away.
After watching this, India, a question. Why does the test simulate a window opening, and why is that important?
Yeah, so the window opening and its location in the test specimen exposes both interior and exterior faces and the full cross-section of the wall assembly to fire. The final test result is for the entire assembly system, not any individual component or detail of the assembly. Treatment of the perimeter of the window opening, for example, how it's closed, will have different influences on performance based on the wall assembly's cross-section and composition and vice versa.
Okay. So can you discuss any recent updates to the standard?
Sure. One very recent and important update to the standard is the inclusion of a new annex that provides useful information and guidance for consideration when performing evaluations of modifications to NFPA 285 tested assemblies. It's called Annex B Guide for Extensions of Results from Assemblies that Meet NFPA 285 Test Requirements. That's a mouthful. Fire protection engineers practicing in the space of fire testing and the building envelope should find the content of Annex B extremely useful when evaluating test data against proposed designs for wall assemblies that are required to be tested to and comply with NFPA 285.
Fantastic. Well, thank you, India, for sharing details about how NAMBA is addressing fire safety.
Sure. Thank you very much for having me.
Yeah, and thanks for joining us for this consulting specifying engineer discussion. For more info about fire and life safety, please visit www.cscmag.com. And until next time, thank you and goodbye.